All right, so we're going to look at graphing linear equations using a t-table. Now, in the word linear, what word do you see? Line. So when you have a linear equation and you're asked to graph it, you're actually graphing a line. And the form of a linear equation looks like this. So basically, it's going to have this form. It'll look something like ax plus by equals c, something like that. So notice there's going to be an x, there's going to be a y, so there are going to be two variables. Not always two variables, you're going to see that as well. But for the most part, you'll have two variables. And notice the exponents of the variables are what number? The exponent of the variables. What are the exponents?
They don't have exponents.
There is an exponent. What is the exponent? 1. If there's no exponent there, remember it's understood to be a 1. So the linear equations have exponent of 1. Okay? All right, so that's one form. The other form you could see it in is something like this, y equals mx plus b. That's another form. And you did this in Math 98, where when you get y by itself, that's called slope-intercept form. So you may remember that. That's called slope-intercept form. Slope-intercept form. And one of the sections in Math 98, when you did y equals mx plus b, was to graph this line using the y-intercept and using the slope. Now that's not what this section's about, though. This section's about just using a t-table. So when you do the worksheet, you have to graph the line. If it says using a t-table, you have to graph it using a t-table. Okay? All right. So, for example, let's look at this linear equation. So we're going to graph this linear equation. So number 1, x minus y equal 4. X minus y equal 4. All right, now, in my math lab, when you get to my math lab, you're going to have something that looks like this. They'll have a t-table already there. So remember t-table, you have the x column and then you have the y column. And they're going to have 3 sets of points in my math lab. They're going to have, let's say, 1 here, and let's say here they have 3. And then let's say for the x coordinate here, they have, let's say, -1. Okay? So I'm going to circle the ones that were given. So you were given this x value is what number? 1. This y value is what number?
3.
And this x value is what number? -1. Okay. So in my math lab, when you do my math lab, I think there's just one problem like that where they give you these values and you have to find the other value. So if x is 1, how do you find this y value right here? Do you remember what to do? You replace or you substitute x with 1. So where we see the variable x, you plug in 1. All right, so we get this. We get 1. Remember, x is 1, right? Minus y equal 4. So I got to get y by itself. What's the next step? Subtract 1 from both sides. Very good. So you subtract 1 from both sides. Notice mathematically, whatever you do to one side, you do the other. So you see I'm showing subtract 1 on both sides. All right. Then we combine like terms. When I combine like terms, what's 1 minus 1? 0. But what's left over here? Negative y. I'm going to write as negative y for right now. And over here, what do I get? 3. All right, now remember, negative y can be rewritten as what? Negative 1y. So negative 1y equals 3. Now remember, you're trying to solve for y, correct? All right, so to get y by itself, and when I say get y by itself, I mean a positive 1y. Right now, what do I have as a coefficient, though? Remember, notice I used the word coefficient. Coefficient is the number you're multiplying the variable by. So we're now multiplying y by -1. What's the opposite of multiplying by -1? Divide by -1. Now, some of you have a habit of dividing by -1y. You don't divide by the variable, you divide by the coefficient. So don't make that mistake. It's mathematically incorrect. So everything you write has to be mathematically correct. So what's negative 1 divided by negative 1? 1 times y is, so what's my y value? Negative 3. So in my math lab, in that t table, you're gonna type in negative 3. So when x is 1, my y value is negative 3. Okay? Then you do the same thing for the next point. This time, though, for this one, you're told that 3 is the value for what letter? Y. So I go back to the equation, and wherever I see the variable y, I'm going to plug in 3. So I get x minus 3 equals 4. And this one's a little bit easier to deal with. How do you get x by itself? Add 3 to both sides. Combine like terms. 3 to negative 3 is 0. So what's left on the left side? And what's x equal to? 7. So in my math lab, on that t table, you would type in 7. Now, before we go into the next one, keep in mind that what you're finding here are solutions. You're finding solutions to this equation. So it's kind of like saying, if you had x minus 4 equal, let's say, 6, what's the value for x that makes this equation a true statement? 10, right? So x equal 10, that's a solution. So whenever you're finding the values of the variables that makes that equation true, you're finding the solution. So all these right here, this 0.13 is a solution to this equation. Because if I were to plug in, let's do this one, this one's easier. If I were to plug in 7 for x and 3 for y, this side would equal that side, right? So 7 minus y is 3. What's 7 minus 3? 4. So 7, 3 satisfies this equation, so that's a solution. Same thing here. 1, let's look at this one right here. 1, subtract y, what's y? Negative 3 equal, and I want to see that's equal to 4, right? Remember, when you have a subtraction, always change it to an addition problem. So 1 subtract a negative 3 means the same thing as 1 plus what? 3, which is what? 4. So that's a solution as well. So all these are solutions. So when we plot the points, you're going to notice that you're plotting the solutions to that equation. That's what you're plotting, solutions to the equation. All right, let's look at this one. When x is negative 1, I get negative 1 subtract y equals 4. All right, what's the next step? Add 1 to both sides. Good. Plus 1, plus 1. What you do one side, you do the other. What's negative 1 plus 1? 0. Now, what term, I use the word term, is on the left side? Negative y or negative 1y, does not matter. Equal, and what does that equal? 5. And so remember, it's trying to get y by itself. Right now, I have negative y. For some of you, you may want to rewrite this as negative 1y. All right, remember, you got to get y by itself. So what's the coefficient? We use the word coefficient. What is the coefficient of y? Negative 1. So which means that I'm multiplying y by negative 1. What's the opposite of multiplication? Division. So I divide both sides by negative 1, just like this. Not negative 1y, because that's mathematically incorrect. It is negative 1. What's negative 1 divided by negative 1? Positive 1. 1 times y is? So what's my y value? Negative 5. Right. So I found another solution. How many solutions does that linear equation have? An infinite number. I can keep on going, right? I can use decimals. I can use fractions for x or y. Infinite number. How many solutions did I find? 3. 3. I found 3 solutions. The solutions are written as a point, though. Okay, so what we're going to do now is plot the points. So I gave you a grid paper. So on your grid paper, you're going to, yes? On that grid paper, you're going to plot that point, those 3 points. All right, now you have to remember how to plot points. Someone else may walk in, just put them aside. You plot those 3 points. So the first point that I'm going to plot, now these are called points. The first point I'm going to plot is what point?
Y.
No, tell me the point though. What point? 1, -3. That's how you read it. When I say tell me the point, you say just 1, -3. Is that correct? 1, -3. All right, now remember how to plot a point. You start at the origin. The origin, use the word origin. So remember, where is the origin located? Where the x-axis and the y-axis intersect. Right here. That's the origin. Where the x-axis and the y-axis intersect. All right. Now remember, I'm plotting the point 1, -3. Is that correct? All right. So always start with x. X is a positive 1, right? Since it's positive, I go to the right. If it were negative, I'd go to the left. If y is positive, I go up. If y is negative, I go down. All right. So always do x first, though. All right. So I start at the origin. I don't put a point there. I just have my point right over it, the pencil point. And so x is positive 1. I go to the right one. I don't put a dot there because you have to have an x and a y coordinate. And then y is -3. So where do I go? Down 3. So this right here, now you put your point, you plot your point. I plotted my point. Now, I think on that worksheet it says you have to label, right? If it says label, it means tell me what those coordinates are. So you're going to say in parentheses, you're going to say 1, comma, -3, parentheses. So that's what I mean by labeling. Okay? So that's the point 1, -3. Now we talked about quadrants in 98. Where is this point located in terms of quadrants? In what quadrant? You remember the quadrants?
4.
Quadrant 4. All right, so this right here is quadrant 1. You go counterclockwise. Quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. All right. Now to graph a line, how many points do I need? 2. But you can always make a mistake, so it's always a good idea to use how many points? 3. Those points have to lie in the same line. All right, so hopefully these 3 points I found are going to lie in the same line. All right, so the next one's 7, 3. Again, where do I start? At the origin. X is 7, positive, so I go which way?
Right.
To the right, 7 units. So here I am right here. And then y is a positive 3, so I go up 3 right here. So I label that point. I label the point, so that's the point 7, comma 3. Again, make sure you do 3 points just in case. Just in case you made a mistake with the computation. And then the last point is -1, -5. So I go which way?
Right. I mean left.
To the left 1 and then down 5. So that's about here. Now, towards the end of the period, I'll give you about 5 or 10 minutes where you can start working the worksheet. You're going to use a ruler though. So don't draw this by hand. I need for you to use a straight edge. So either use your driver's license or edge of a book or something. So you're going to get a ruler at the end. So you just draw your line, and those points do lie on the same line. Now, several things. You need to extend the line, make it go through the points. And what else do I need to draw? Is this draw the arrows? If you don't draw the arrows, you're going to be very upset with me when you get your worksheet back. All right. Okay, so that is the line for x minus y equal 4. Okay, so that's x minus y equal 4. All right. Okay, let's look at the next one. Now, suppose we had this linear equation. Okay, number 2. Suppose we had y equals negative 2/3 x plus 5. Y equals negative 2/3 x plus 5. All right, now y is by itself. So usually when y is by itself, it makes things a lot easier for us in terms of finding points. But notice that the coefficient of x is a fraction. So you need to be strategic with the values for x that you choose. For example, if you let x be 2, you're going to be dealing with fractions, right? Because then you have to say, if x is 2, you'd have to say negative 2/3 times 2 is a negative 4/3. Then you have to add that to 5, so then you would have to find your least common denominator and all that. You would end up with a fraction. Then you have to estimate where that is in the grid. So you don't want to do that. Whenever the coefficient of x is a fraction, you want to be strategic with the number for x that you choose. My denominator is 3, right? So what you want to do is choose numbers that are divisible by the denominator. So choose values for x. Choose values for x that are divisible by the denominator. That's going to help you. All right. So my denominator is 3, right? So what numbers are divisible by 3? And when I say divisible by 3, I mean I get a remainder of 0. Give me a number that's divisible by 3, huh? 0. 0 divided by 3 is 0. What's another number divisible by 3? 3. 3 divided by 3 is what? 1. What's another one? Negative 3. Very good. Negative 3 divided by 3 is negative 1. The remainder is 0. So you see what's happening? So what's the next number that's divisible by 3, the next set? 6, negative 6. What are some others? 9, negative 9, and so on. So using those numbers will make sure that these numbers for y will be integers. You won't have any decimals, you won't have any fractions. But we don't need all these. We just need how many? 3. So I'm going to use the first 3 that we mentioned. I may do 6 as well, just to remind you how to multiply fractions. So if x is 0, that one's a little bit easy, because when x is 0, I get this. I get y equals negative 2/3 times 0 plus 5. No, agree? But remember, order of operations. Here I'm doing multiplication and an addition. What operation do you do first? Multiplication. Negative 2/3 times 0 is just 0. And what's 0 plus 5? 5. So I found one of my points. One of my points is 0, 5. That's one of my points. All right, if x is 3, let's talk about that. If x is 3, I get y equals negative 2/3 times 3 plus 5. All right, negative 2/3 times 3 plus 5. Now, a couple of things you can do here. Again, though, which operation do I do first? What's the operation? Multiplication. So I'm going to circle the multiplication part right here. And I'm going to go off to the side, just kind of remind you. This is what I rewrote this, just to remind you what to do. Now, if you want to, you can write 3 as 3 divided by 1, right? Now, two things you can do. First, you can reduce and then multiply, or you can multiply and then reduce. It's up to you. Let's suppose we multiply first. When you multiply fractions, you multiply numerators. What's a numerator? No, not 5. You multiply negative 6. Negative 2 times 3 is a negative 6. What's 3 times 1?
3.
And then reduce. What's negative 6 divided by 3? Negative 2. All right. Or you could have reduced first. These 3's divide out, right? 3 into 3 is 1. 3 into 3 is 1. Now you multiply. What's negative 2 times 1? What's 1 times 1? What do I get when I reduce that? So you get the same thing. But be careful, that is negative 2. But what am I adding to it?
5.
So what's negative 2 plus 5?
Negative 3.
3. So I found another point. The other point is 3, 3. I found another point. All right, let's let x be negative 3 this time. See what we get. So if x is negative 3, I get y equals negative 2/3 times a negative 3 plus 5. Negative 2/3 times a negative 3 plus 5. I do multiplication first, but remember a negative times a negative is a positive. So when I multiply these two fractions, or these two numbers, it's going to be a positive number. All right, so if you need to, and you don't have to do all this work, but if you need to, go ahead and rewrite it. You can multiply first. What's negative 2 times negative 3? Positive 6. What's 3 times 1? What do I get? 2. Or you could have reduced first and then multiply. But regardless of which approach you take, this product is 2. And then 2 plus 5 is 7. Let's do the 6. If x is 6, I get y equals negative 2/3 times 6 plus 5. Y equals negative 2/3 plus 6 plus 5. And again, we're going to multiply first. So if I go off to the side and figure out what that is. All right, so I'm gonna do both. So let's multiply first. If I multiply first, what's the numerator? What's the denominator?
3.
What do I get?
Negative 4.
Okay. Or I could have reduced first. 3 into 3?
1.
3 into 6?
2.
All right, now multiply. What's negative 2 times 2?
Negative 4.
What's 1 times 1?
1.
What do you get?
Negative 4.
All right. So regardless of which approach you take, you get the same value. All right, but that's negative 4 right here, so that's negative 4 plus 5, which is 1. All right. So if I were to plot all those 4 points, they better lie in the same line, right? Okay, so let's go ahead and plot those points. Now notice I used a t-table, so that if it says use a t-table, use a t-table. Make sure you follow directions. All right, so 0, 5. 0, 5. All right, where do I start? At the origin. At the origin, though. X is 0. So that means I stay there. Because x is 0. Y is a positive 5, so where do I go? Up 5. So 0, 5, this right here, if I label it, it's not in a quadrant. It lies on the y-axis. All right, so 0, 5 lies on the y-axis. So there's a point, 0, 5, and I labeled it. Labeling means you say 0, 5. What's the other point? 3, 3. All right, so I start the origin. I go to the right 3, and then what? Up 3. So there's the point, 3, 3. What's the other one? Negative 3, 7. All right. So I start the origin, go to the left 3, and then up 7. So negative 3, 7. And then if I were to do the other point, it would lie on that same line, right? The other one, I think it was negative, it was 6, 6, 1. So 6, 1 is here. So notice all those 4 points lie on that same line. And then if you draw the line, again, make sure it goes through those points. Extend that line just like this. And don't forget to draw your arrow. All right, so that is the line y equals negative 2/3 x plus 5. All right. So let's do one more with a fraction and we're not going to do 4, we're just going to do 3 points. All right, let's suppose I had this. Now, let's suppose I had the point, the equation y equals 1/5 x minus 2. All right, I use a t-table. Y is by itself. Makes things a lot easier for us if Y is by itself. I use a t-table. I want to choose numbers that are divisible by what? 5. What number is always divisible by non-zero number?
0.
0. Always use 0. So if x is 0, I get y equals 1/5. Right. You didn't have to do all that work. But 1/5 times 0 is 0, and 0 subtract 2 is a -2. Good. All right, I need 2 more x values. 5 and -5. 5, -5. All right. So if x is 5, I get y equals 1/5 times 5 minus 2. So I have to multiply first. What's a fifth of 5? 1, right? And 1 minus 2 is a -1. Okay. -5, I get y equals 1/5 times a -5 minus 2. All right, let's do the multiplication first. A positive times a negative is a negative. All right, so let's go ahead and look at this one. I have 1/5 times a -5 over 1, right? If I multiply first, I get what's 1 times a -5? The denominator, what's 5 times 1? What's that reduced? -1. So I get -1 subtract 2. Remember, -1 subtract 2. Always change. If you have trouble with your signed numbers, use your calculator. But basically, you got to remember, you change this to an addition problem. So this becomes -1 plus a what? -2, which is -3. So if those points do not lie in the same line, then you did a computation error somewhere. So you got to go back and figure out what that error is. So you have 2 more grids on the back side. So turn the back side, and then do that on the back side. All right, number 3, my points are 0, -2. So I start at the origin, and I stay at the origin because x is 0. But then I go down 2. If it says label, that's what I'm saying. I want you to tell me what those coordinates are. The x coordinate is 0. The y coordinate is -2. What was the next point?
5, -1.
5, -1. All right, so I go to the right 5 and then down 1. So that's the point. 5, -1. And then what was the other one?
-5, -3.
-5, -3. All right, so I go to the left 5 and then down 3. So -5, -3. And then I use a straight edge. Extend the line and draw your arrows. Okay, number 4. All right, let's look at number 4. Now, notice in the 3 problems we did, the linear equation had both an x and a y, right? So it had both an x and a y. Let's look at number 4. Number 4, I have this linear equation. This is a linear equation. Even though you don't see the variable x, it's still a linear equation. Y is being raised to what power? 1. And when I graph it, you're going to see that it is a line when you graph this. But when you only have one variable, the way you want to think about this is this way. T-table. This one's a little bit easier to deal with, although students sometimes get a little messed up with it. This says that y has to always equal what? 3. That's what that says. Y has to be 3. The one above said that y depends on what x is. That's what that said. So whatever x was, I had to first of all multiply by half, and then I had to subtract 2. So that's why you saw that all these y values were different. They were different. But here, there's no x value. So that means that y will always equal 3. So my y column will be what number?
3.
3. All the way down here, y is always equal to 3. That's what that says. No matter what x is, y is always equal to 3. No matter what x is. So x could be 0. What's y? 3. X could be 1. What's y? X could be negative 4. What's y? And so on. And so if I plot those 3 points, 0, 3, 1, 3, negative 4, 3. Okay, so 0, 3 is on the y-axis. 1, 3 is in quadrant 1. Go to the right one, up 3. 1, 3. And then negative 4, 3 is right here. What kind of line is this? Horizontal line. So that's a horizontal line. So you get this horizontal line. So that's y equal 3. And it kind of makes sense because notice that no matter where you are on this line, if you look at every point, what is the y value of all these points right here? 3. That's what that says. All these points, my y value better be 3. All right. Let's look at x equal negative 6. X equal negative 6. Number 5, x equal negative 6. So again, this is linear. When we draw this, you're going to see that it is a line. But again, the y is not there. You only see one variable, x. Just like what we talked about earlier in number 4, this says that x is always equal to what? Negative 6. That's what that says. No matter what y is. So if I do a t-table, this time my x column is going to have what numbers? Negative 6. And I just need 3 of them. So x will be negative 6 no matter what y is. So y could be 0, y could be 5, y could be negative 2, and so on. So if I plot those 3 points, I get negative 6, 0. Negative 6, 0. I'll start at the origin, go which way? To the left 6. Y is 0, so that means I do what? Stay there. So the point negative 6, 0 is on the x-axis. What's the other point? Negative 6, 5. All right, so I go to the left 6 and then up 5. That's negative 6, 5. And then one more. Negative 6, negative 2. All right. And notice when I draw my line, this is what kind of line? Vertical. That's a vertical line. All right. Okay. Now notice the first 3 we did where we had 2 variables. And then the last 2, 4 and 5, where we had 1 variable. So notice the 2 variables, the lines either, and remember you read a graph from left to right, so the line either rose or it fell. So it was kind of a slanted line, so either rose or it fell when you had the 2 variables. When you have 1 variable, either it's horizontal or it is vertical. Okay? In number 6, let's suppose you had number 6. we had y plus 2x equal 3. Y plus 2x equal 3. Is this going to be a horizontal line or a vertical line? No, it won't be horizontal, nor will it be vertical, because you can see how many variables there. 2. All right. Now, what I would do there is actually get y by itself. I would get y by itself. So if I get y by itself, you would have to do what to both sides? Subtract 2x. Combine like terms. 2x and a negative 2x is 0. So I get y equal. Now before I go on, are these two terms like terms?
No.
No, good. So always put the x term first, though. So how are you going to write this?
Negative 2x.
Negative 2x plus 3. Negative 2x plus 3. Y'all agree? Okay. Don't say that's 1x or 5x, because they're going to be like terms. That's not a 3x, that's a 3. Okay? Negative 2x plus 3. Those are not like terms, so you have to leave it as two terms. Negative 2x plus 3. All right. Now, use the t-table. How many points do I need?
3.
Okay, what's the easiest number to use for x? 0. So if x is 0, I get y equals negative 2/3 times 0 plus 3. What's negative 2 times 0?
0.
And what's 0 plus 3?
3.
3. Do I have to worry about divisibility here? No. I don't have any fractions. So I don't have to worry about specific values for x. Give me another number for x. 2. Okay, if x is 2, I get y equals a negative 2 times x. X is 2 plus 3. What's negative 2 times 2? And what's negative 4 plus 3? Negative 1. All right, I need one more. Give me another value for x. Doesn't matter. Negative 2. All right, if x is negative 2, I get, if x is negative 2, I get y equals negative 2 times negative 2, right? Plus 3. What's a negative times a negative? And negative 2 times negative 2 is a?
4.
4 plus 3 is? 7. All right. Now, if you're doing this correctly, they all should lie on the same line. If you need more grid paper, just take one, just pass this back. All right, so I plot those points. 0, 3. So the grid paper is being passed around if you need more. The other point is 2, negative 1. So I go to the right 2 and then down 1. Is that correct? Okay. And then what was the last point? Negative 2, 7. So I go to the left 2 and then up 7. So I get this. You agree? And you notice that they will lie in the same line. So I draw my line. All right, I could have done a little bit better job with plotting those points, but we're done. Okay? All right, so that was the line. Y plus 2x equaled 3, or you could have said y equals negative 2x plus 3. All right, now let's look at one more with the t-table. One more with the t-table. Okay, so there's going to be number 7. Number 7. All right, suppose this time I had this. I had 4y equal negative 5x plus 8. 4y equal negative 5x plus 8. Make things a little bit easier on yourself, just like we did number 6. What did we do in number 6? We got what letter by itself? Y. So let's try and do the same thing in number 7. How can I get y by itself in number 7? Divide both sides by 4. All right, now this is how it looks, though. You got to remember something from a previous course. When I divide both sides by 4, what you do to one side, you do to the other. So I'm going to go ahead and rewrite this over. I'm just writing it over, and I'm going to say divide by 4, divide by 4. Okay? What I do to one side, I do to the other. Now we have to reduce next and simplify. The term that's on the left, that's easy to deal with. 4 divided by 4 is 1. 1 times y is y. All right, now you have to remember how else you can write the right-hand side. For example, if I had 10 plus 2 divided by 2. Y'all know that 10 plus 2 is 12, right? And then, so that's 12 divided by 2, which is 6. Could I also have said this? Could I also have said 10 divided by 2 plus 2 divided by 2? So take each term that's in the numerator and divide it by the denominator. What's 10 divided by 2? And 2 divided by 2? And you still get 6. So what you want to do here is what we did here. Write this as 2 fractions, or 2 terms. So this becomes negative 5x divided by what? 4. Plus 8 divided by what? 4. And then reduce. What part of this can I reduce? 8/4. So this becomes y equals negative 5/4 x plus what? Now 1/2. 8 divided by 4. Not 4 divided by 8. 4 divided by 8 is 1/2. What's 8 divided by 4? 2. 8 divided by 4 is 2. So that's what you want to do here. So on that worksheet in my math lab, you're going to see something like this. So you want to get y by itself first. Remember something you've had many years ago, right, with this part here. And then do the same thing with this, right? It's 2 terms. And now we can do it like a couple problems did at the beginning of the period. Be strategic. What values of x do you want to use? Values that are divisible by what? 4. What's the easiest to always use? 0. Okay, what's the next one? 4. And what's the other one? Negative 4. Okay. So if x is 0, I get y equals negative 5/4 times 0 plus 2, right? What's negative 5/4 times 0? And what's 0 plus 2? 2. All right. Let's do 4. Y equals negative 5/4 times 4 plus 2. All right, let's get this product. If you need to go off to the side, then do that. Negative 5/4 times 4 over 1. If you have to multiply first, then that's fine. If you want to reduce first, that's fine as well. Reducing is probably easier or quicker. Well, 4 divided by 4 is? 4 divided by 4 is? All right, what's negative 5 times 1? 1 times 1? What do you get? All right, but be careful. That's negative 5 plus 2, which is negative 3. All right, and then one more. If x is negative 4, I get y equals negative 5/4 times negative 4 plus 2. Remember, a negative times a negative is a positive. All right, so we have negative 5/4 times negative 4 over 1. If you need to multiply first, that's fine. What's negative 5 times a negative 4? Positive 20. What's 4 times 1? And what's 20 divided by 4? 5. But that's 5 plus 2, which is 7. All right, and then you plot those 3 points, and then you have your line. I'm going to plot those points. And when I plot the points, I'm going to get, so 0, 2 is on the positive x-axis. 4, negative 3 is in what quadrant? 4th quadrant. Right 4, down 3. And then one more point, and that was negative 4, 7. Negative 4, 7 is in what quadrant? 2. So to the left 4, up 7. Huh? All right, and then I draw my line, and you are done. Okay. All right, so that was that part of graphing linear equations using what idea? T-table. Using a T-table. So notice in each of those I used a T-table. So I showed the T-table. So when you do your worksheet, make sure you show the T-table, even when it says y equals a number or x equal a number. Still use the T-table just like I did. Okay? All right, so that takes care of that one section. Now I just want to mention something about the second section. And that's this. All right, listen carefully. So the second worksheet that you're going to get, and I'll give it to you next class period, but the second worksheet you're going to get has to do with intercepts. Intercepts. All right, intercepts. All right, graphing lines using intercepts. Now, if I were to go back and just look at two of these for the moment, two of these, this point that I'm pointing at right here, this point right here, that point is called the what? X-intercept. The x-intercept is where the graph crosses the x-axis. This point right here is called the y-intercept. That's where the graph crosses the y-axis. So you have the idea that the x-intercept is the point where the graph, and in this case we're talking about a line, where the line crosses the x-axis. And then the y-intercept is the point where the graph crosses the y-axis. Do you all agree? All right. Now, a couple of things you're going to need for the next class period, and that's this. I want you to think about this. All right. Look carefully what I'm doing. So I'm drawing this line right here. Let's say I have this line and it crosses the y-axis at this point right here. What are the coordinates of that point that I just drew? 6 what? I'm sorry, 0 what? 0, 6. If I do this one, 0, 3. If I do this one, 0, negative 4. The point being that no matter where the graph crosses the x-axis, you notice something in common with one of the coordinates. The x-coordinate is always what? 0. The x-coordinate is always 0. So the other thing you need to remember, we're going to need this for next class period, is that the x-intercept, the y-coordinate, is what? Is what number? 0. So for the x-intercept, no matter where the graph crosses the x-axis, the y-coordinate is always going to be 0. So the x-intercept, oh, you know what? I said Okay, y'all didn't say anything. I said the x-intercept, right? That's the y-intercept. Yeah, I'm sorry. The y-intercept, because I said y-intercept. The y-intercept, the x-coordinate is what? 0. All right, x-coordinate is 0. The y-intercept, though, let's go to the y-intercept. I'm sorry, the x-intercept. X-intercept. Here? What are the coordinates right here?
0, 4.
Oh,
I mean, 4.
4, 0. Right here? What is it?
2, 0.
Negative 2, 0. Right here?
9,
9, 0. So where the graph crosses the x-axis, what do you notice about the y-coordinates?
0.
It's 0. Where the graph crosses the x-axis, the y-coordinate is 0. So for the x-intercept, the y-coordinate is what?
0.
0. So we're going to use that idea in the next class period. So you're going to see that when we graph the next set of lines using intercepts, we're going to use zeros. So again, when the graph crosses the y-axis, that's the y-intercept. What is the x-coordinate always? 0. And you don't have to memorize that. Just look at it. Just look at a line that crosses the y-axis, and then kind of ask yourself, what's my y value? My x value. My x value is 0. No matter where you are, the x value is 0. Where it crosses the x-axis, the y value is what?
0.
0. Okay. All right. So you're not leaving, because remember the class is from 6 to what? 7:15. All right. So I'm going to give you worksheet 1.